Okay, and we're live. Okay, so I just want to cover what I posted in the slide decks really quick. So in the main, let's see, in the main class thread post, whatever the class thread post, where I posted the Zoom link. Underneath that, there's a little section that says slide decks, and I have some slide decks in there. Those are just the materials that I'll cover. That's what I'm presenting in my text editor on the right hand side. That's what you can access. If you click those, you'll go to the GitHub course repository where all the materials are, and you can access those there. I recommend that you have those pulled up so that you can kind of follow through with what I'm going through. Also recommend that you have a REPL pulled up, just an environment of some kind. Excuse me. You can start with Replit if you don't have VS Code or some other local environment set up yet. That way you can kind of code along with what I'm doing. If your code hits a snag or something, you can post it, you can talk about it, hash it out. You might learn something interesting doing that. So that's the way I recommend you do this. Obviously, I know people got lives, and you might be doing something else as you're watching this, and that's okay too. So, but if you have the bandwidth to do those things, that's what I recommend. So it's not likely that we'll get through all three of those today. As you've seen, like, we tend to get through most of one slide deck at a time in class, which is pretty intentional. I'm trying to go very slowly and methodically through everything so that we're just thorough and get to spend plenty of time. We're not rushed. So that being the case, I don't have any particular need to get through all of that today. It's just, this is kind of what we're going to be talking about, or what's going to be coming up next. So do feel free to ask questions as we go through the material as I'm talking. I'm not always checking Slack, but I try to check it fairly often, and I'll respond to questions as soon as I find a breaking point where I can do that. So do feel free to ask questions. If you want to answer each other's questions, I'm fine with that too. It's not going to bother me if there's like a side conversation, as long as it pertains to the material. If somebody asks a question and you want to chime in and give an answer to that, that's totally cool too. I may also chime in and give an answer as well. All right, let's jump into things. So, oops. Let me open these up. Functions. Today we're going to be talking a lot about functions. Hopefully, if all goes as planned. So I do want to do a recap. I want to do the overview, and I want to do a recap of what we covered last time, which is control flow. It's a pretty central and important set of concepts. Doesn't all need to be mastered at this point, but I want to make sure that we have a solid foundation moving forward. I want to do just a real quick survey. One, 2, or 3. How are you feeling about variables? 1 is like you're totally lost with variables and you don't understand them. 2 is like you've got it, but maybe you have some questions. And 3 is like, yeah, I basically get the idea. I'm getting a lot of 3s. Okay, yeah. Well, I won't make any assumptions. Okay. Good. All right, a couple 2s. Okay, I'm seeing a couple 2s, but no 1s. Thank you. If anybody, if we've got any 1s in here, don't hesitate. If you've got any questions about variables, feel free to DM me, or you can save questions for after class, and we can go through that. I don't want to leave anybody behind on that or anything else, but just wanted to make sure we're solid there. Let's do the same thing for here. Let me make a separator here. Okay, control flow. Let's try that. 1, 2, or 3 with control flow. Okay. If you've got a 1, don't be shy. I won't judge you. I mean, I'll take it as a personal criticism of my teaching style, but you know, I won't let you see me stay up at night, so don't worry. Just kidding. Okay, cool. So we got some more 2s. I'm not being super scientific about this, but it looks like we got more 2s than 3s. That's okay. That's kind of what I'm expecting. So I want to do, we'll sink into a bit of a recap on control flow. We don't necessarily need everybody like at a 3 right now. You know, we'll solidify these ideas as you go. But we'll have a bit of a recap and sink into that a little bit. And maybe we'll have time for questions. I want to do the overview first. And as usual, I'm going to let you do it first. You probably refer back to notes if you have the overview. You know, I mean, you've seen me do it before, and I'm going to do it after you all do it. But rather than looking at notes, try to do it from memory. It doesn't need to be exactly what I have. The idea is that you're trying to paint a picture of what a complete set of tools looks like for knowing Python. So you can approximate my overview, or you can go off the rails and do your own thing, or just try to do the best you can from memory. So try to get in the overview in Slack. I'll let you all do it first. Wow, cool. All right. Well, I've succeeded in driving that home pretty well. Cool. It seems like, again, I'm not reading all of everybody's answers here. We'll give a couple more minutes. The answers are in Slack, so look only if you want spoilers. If you copy paste somebody else's answer, no one will ever know. No, but I do want you to do it from memory if you can, or to think through it. All right, 10 more seconds ish. Great. Cool. We'll wrap up there for that. You can still get in an answer, but I'm going to move forward. Thank you very much. Awesome. I'm really happy to see that people really have a pretty solid handle on this. That's great. And if you didn't get an answer, you know, Of course, I'm not trying to put you on the spot. It's all good. All right, so I'm going to still go over this again. I'll be pretty quick about it. I did notice we got a few new people who trickled in since then. Go ahead and put in an emoji in the thread. That'll help our attendance metrics to know who's here for the day. So go ahead and do that now if you don't mind. Here, let me just say attendance. Just the folks who came in. If you already put in a hello emoji, you don't have to do it again. All right, cool. Thank you very much. Yeah, we're gonna get into iteration here pretty soon. Cool. So let's do the overview again real quick. So the overview, as I reckon it, we've got data types. You want to have a solid understanding of your types, abstractions, control flow, and iteration, which we're going to get into iteration here in a second. Today, we're going to recap. We're going to start recapping control flow, which is what we did last time. And we're going to do, most of today's material is going to be about functions, which is part of abstractions. So let's just quickly recap the data types that we've done. Actually, I'll leave it to you again. Actually, let me just delete that then. What are the data types that we've covered? Go ahead and put it in Slack. Great. A lot of good answers there. All right. Go ahead and put in your answers if you've got them. Okay, so I'm gonna do mine. We've got int, float, and don't worry if you're not laying yours out exactly like I am. I have my way. You may have yours. We've got int and float, which are our sort of traditional numbers that we think of as numbers. These are what we think of as base 10 numbers. Obviously, floats express a number with a fractional component. Integers express whole number values only. Either one can be positive or negative or zero. So just so you know, bool is technically a numeric type, although it doesn't really conform to what we usually think of as a number. It has two values, which are true and false. Other data types in Python can be cast to Booleans or be kind of implicitly understood as Boolean values where Boolean values are expected. So that's called truthiness and falsiness. So a given value of an integer or a float or a string or another data type may be true in a truthy state or a falsy state depending on what it is. So with integers and floats, if the value is equal to 0, it's falsy. All other states, positive or negative, small or large, close to 0 or far from 0, are considered truthy, all other states. Cool. We also talked about strings, str, none, and I think that's it. Ooh, why do I think I'm missing something? Cool. There we go. Nice. So that's the data types we've covered. These are not all the data types in Python, but these are the ones we've talked about thus far. Abstractions, we have variables, which I think everybody's good on variables, which is great for the most part. Again, if you have questions, feel free to DM me or stay after class and we can go over, hash those out. And functions, which is going to be today's topic. This is going to be today's main topic. There we go. Control flow, last session's main topic, so we'll review this today. Who remembers the 3 keywords for control flow? Go ahead and put it in. Yeah, there you go. Beat me to it. Great, yeah, we've got if, elif, and else. I think I saw a for in there as well. So for actually is going to go in loops. This is a thing. If you're learning about loops and you're like, oh well, that seems like it should be part of control flow. As it happens, I agree. The term control flow sure makes it kind of sound like it's going to involve loops somehow. However, canonically, officially, it just has to do with conditions, just if, elif, and else. It's kind of a disappointing definition, but that's what it means. So, in my opinion, disappointing. But yeah, so control flow is just if, elif, and else. This is just condition checking, checking if something's true or false, and executing or not executing code according to that. And the if, elif, else keywords are sort of our basis for the logic around that. And then iteration, I already hinted, we have for loops, we have while loops. These are the 2 main types of iteration constructs that we're going to get into in this class. We're also going to mention something called comprehensions, although it's not something, it's something that you want to know exists. It's not something that you necessarily need to master at this time. They're actually slightly less powerful than for loops. So in terms of just being able to get things done, for loops and while loops cover most cases of times that you're going to need an iteration strategy. There's also an iteration strategy called recursion, which actually doesn't have a specific like for or while construct. It's actually a way of using functions to call themselves infinitely or recursively. It's really cool. If you know about it, you know how cool it is, or potentially you think it's intimidating. We're not going to get into recursion, although it is very, very powerful. So there's a few iteration styles and strategies that we're going to cover shallow or not get into really that much at all. So what we're going to focus on is for loops and while loops, just so you know. And hopefully it's clear, but like I said, that's going to cover most of the problems that you're going to encounter are going to be solvable with for loops and while loops. Most of the problems that require some form of iteration. So yeah. All right. So that's that. That's the overview. So let's do a bit of recap with control flow. So let's say I'll make up a little breakout for us. Let's say I've got A equals B. Oh, what am I doing? A equals 10, B equals 7, and I want to run a print line that says A or B is greater than or equal to, I want to basically run a print that says A is greater than B when A is greater than B, or B is greater than A when B is greater than A, or they're equal if they're equal, right? So that gives me 3 possible prints that I might want to run. So given something like that, go ahead and write some code, some control flow code that will print out the appropriate response. Real quick here, I want to cover, sorry, I'm realizing we need to cover code formatting in Slack. So I want to show you something. Um, so what I just pasted in, you can see has an outline around it. Yep, and this is somebody's showing another technique here, which is also useful for single lines. The way I did this is, I think there's multiple ways to do it, but the way I like to do it and the way I recommend you do it is to use triple backticks. So if you're not familiar with the backtick key, it's not really a character that many people use unless you're programming something, but it's a little, looks like a single tick quote character kind of. It's just a little backtick shape. It's the backtick key on most keyboards is going to be below the escape key, to the left of the number 1 key in your number row, and above your tab key. So the way I do it is literally, here I'll show you. I go into the Slack message thing and I go backtick, 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 and it'll just give me that formatted cell, and then I can type or paste my code in there, and it'll be monospace. It'll use a monospace font, which is like a font that you'd see in a text editor, and it will retain spaces, so you can paste in formatted code. So we'll do this, we'll kind of treat this as a double exercise. So paste in your control flow code, all lines of your control flow code, including the A and B lines. A and B can have different values. Your print statements can say something, just so long as they kind of vaguely match the control flow logic, and it has to be in a formatted cell. Cool. And if you do the 3 backticks and it doesn't give you the formatted cell, just delete them, click somewhere else, click back, do the 3 backticks again, and it should just pop up in like a little square that you can type right into. Should be fairly obvious. If you're in Slack in the in your browser, by the way, I'm not sure if it's occurring to me, like if you're using maybe Edge or Safari or something, it might not work, but it should work in Chrome or Firefox. It'll definitely work on the Slack desktop app. If you don't have Slack, like the Slack desktop app, I would recommend getting that. It's kind of cleaner and better. Cool. So I'm getting some formatted, some unformatted. You can go edit an answer if you want. If you have a message in Slack, let's see, how would I describe doing this? You can hover over your message, and then there will be the triple vertical dots. You'll click that, it'll say more actions, and then a little past halfway down it says edit message, or you can just hit E and it will let you edit the message too. So if you paste it in and it wasn't formatted, you can edit your message to make it formatted. I feel like most people are figuring that out. Good. Interesting. Okay. So I'm looking through, and I'm seeing a lot of answers here. Um, I'm seeing some mistakes that are cropping up fairly frequently. I think some people copied some other people's code, mistakes and all. um, okay, so there's two things that I'm seeing recurring that I want to address. Okay, cool. For the most part, it's pretty good. So one thing I'm seeing is if A greater B, I'm going to be super lazy about this, though. I'm just going to print A greater B, B less than A. I said I'd be super lazy. I'm not going to be super lazy. A is less than. Oh, no, wait. Aha. Oh, no, I was mistaken. That's not a mistake. That was me misreading people's code. Okay. Never mind then. There is another one. Okay. So A greater than B. Come on. B greater than A. B greater than A. Okay, so if A is greater than B, print A is greater than B. If B is greater than A, print A is less than B. If, or else, print A is equal to B. Cool. So, one thing I saw a few times here on the equal condition, if somebody was saying, like, a couple of people I think I saw do this. Something like, I'll rearrange this a little bit. A equal to B, like this. So there's a problem with this. I'll leave it to you all. What's the issue with this code? Particularly what I have selected, what I have highlighted. Cool, yeah. This is a mistake that I make just like typing things out and saying A equals B. You know, this is a pretty easy mistake to make, so, no worries. It's something that I do on stream and in class constantly and just in my own private coding. So, if I try to do this, I'll get an error. It'll say syntax error, invalid syntax. This is, by itself, this is an assignment of the value of B to A. It's just saying make A equal to make A hold point at the whatever the value of B is also. So we want to make sure you get your double equals in there. Cool. Cool. So let's see. Let's do another one. Let's think of a different control flow scenario. Let's test ranges. We'll say n is a number, and I want to print the strings n is greater than, and then I'll do powers, or not powers, multiples of 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Ah. That'll be easier if I just do this. right? So we'll call these our targets. This is what we want to print when it's true that n is greater than that number. So I won't give you a value for n because you should test this with multiple values of n. I'll give you these, and you can write control flow around those. So I'm going to I'll start off with 2 minutes, and we'll just see how many people get in an answer. If there's not many, I'll extend by a minute or 2. So go ahead and start working. Just to be clear, there's no value of n given. Go ahead and test this with multiple different values of n. You don't have to necessarily test each one. You can if you want. But yeah, just make a few tests, try a few different values of n, delete it, and try something else, run it a few times. So you're working in your text editor. I expect you to be working in your text editor and run the code, make sure it's going to run. That's something I think I've mentioned it a few times, but just to be sure, I don't mind saying it again. I will probably say it a couple more times. I do expect that as you're working through these problems, in the breakouts especially, that you're working in your text editor and you're running your code. I do not expect anybody to develop the skill of being able to just write code directly into Slack and know that that's going to work. If I held myself to that standard, I'd be writing ridiculous code all the time, which I do. I just do it in a text editor, and I find out that it's ridiculous immediately, and that's the trick. You just catch your mistakes right away when you run your code all the time. So. Can people hear me? Oh my gosh, I'm sorry about that. Oh gosh, how silly. Um, that's a real thing. All right, thank you. I'm not sure what led to that. All right. Um, all right, I guess I have to re-explain that part. Apologies. So, um, oh gosh, that's embarrassing. So the new goal now is we have this control flow here that will print all the statements that are true, since what we're saying with this experiment is that it's valid for multiple statements to be true at the same time, right? So for this one, it's valid for all of these prints to run for this number. But what if we only wanted uh, print only the largest single statement that is true, right? So for this one, what we want to do is refactor this code so that only this one runs. If n were between, I guess, 71 to 80 inclusive, it would print this one, for example. So how would we rewrite that code? And I'll give you this as starter code. Yeah, so there's two things you're gonna sort of two ways you're gonna need to change this code so that it prints only the right answer. Only the one answer. Cool. Yeah, some people are saying it. Yeah. Go ahead and show me how you do that with the code and paste it in. And somebody said that was how they solved it the first time. And yeah, I did see that solution a couple times in there. So. Okay, cool. So I'll show a solution for this one. So one is we need to reverse the order of the numbers that we're checking. That's one of the things we need to do. The other thing is we need to change these all to elifs. And we could optionally use an else at the end, but in this case it doesn't matter. So we'll start at 100, we'll go to 90, 80, 70, oops. Cool. Ah, there we go. Oh, I'm like, wait, what? I forgot to change the actual numbers here. Yeah, well, that'll do it. 90, 80, 70, 60, 50, 40, 30, 20, 10. Okay, there we go. So check in reverse order and change to elifs. If I didn't change these to elifs, then we'd sort of just get the same thing in reverse. We'd get, n is greater than 70, 60, 50, 40, 30, 20, 10 instead of the other way around. So the reason I wanted to show this is just to show that, right, like using consecutive ifs versus using elifs, they're logically different. They're used for solving different problems. And the reason I want to bring that up is because I notice a lot of times, and I definitely did this when I was first learning, a lot of times people will try to develop like a simple axiom like, okay, every time I'm using an if, I should always use an else. Not gonna lie, you will hear people that will tell you that. There are philosophies about control flow that vary to opposite extremes. On one extreme, there are people that say you should never ever use control flow ever, which, believe it or not, there are ways around it. There are ways to avoid it. In this form, at least, you still need to write conditional code, But the other extreme is that anytime you use control flow, you should always, end everything in an else. Um, there are paradigms that are oriented around doing control flow that way. Um, and I'm not going to say that either of those are wrong. I think they're kind of domain-specific solutions that have reasons for existing the way that they do. But I don't want you all to worry about those. I don't want you all to orient your coding around that yet. As you develop as programmers, maybe one day you'll grow into one of those philosophies and you'll be like, oh, this seems like a cool way to do things, and you can do it. But for now, you can see, right, sometimes you need a combination of if, elif, else. Sometimes you need consecutive solo ifs like this. Sometimes you need if, elif, right? So just it it's 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 not a very satisfying like rule of thumb, but like with control flow, you just basically need to think through each problem start to finish just thoroughly. Just to think about each problem as unique is what I'm saying, so that you don't get off into something else that's not going to work. Okay, cool. We're about halfway through class, which is shocking to me. So this is a good time for a break. Let's just take a quick 5-minute break. Let's reconvene at 8 after the hour. We can open up for questions. If anybody's got anything quick. I can't believe I was on mute for so long. Okay, that's break time. Cool. Everybody settle in and get ready. We'll get started again. Do please, if you don't mind, putting on your cameras. It does help me. I know it seems kind of like a little thing. It does help me, like if I'm looking around and getting a sense of, where people are at and if they're engaged. Um, that just helps me get a sense of what's going on. If you don't have a shirt on, or you're like, you just need this to be private at the moment, that's totally fine too. I get it. But if you don't mind, please put on your cameras. Thank you. All right. Let's get into functions. Time always flies in these lectures. I get into it and I start having fun. And all right. So let's get into functions. If you've worked ahead and learned, you've certainly seen some functions by now. You've seen me write some functions just as of previews of these. So I'll write a quick function here. So you're already familiar with using print. Print is a function that's built into Python. Another one is type that we've worked with, and there's a few others that you may have seen that are built into Python. So Python has a number of functions built in, and those are good to know, and it's good to know how to use a lot of those. And we're going to talk about not just using functions that are already defined for us, but we're going to talk about how do you define your own functions. So a function, I've always wanted a better term for this, and if an official term exists, unfortunately, I don't know it, but I'm going to call them phases. I'm going to say a function has two phases. One is the definition, so let's call this phases of a function. So one is the definition, and the other I'm going to call the invocation. Invocation. I might have spelled that wrong. I'm dyslexic if I haven't mentioned that, so I'm letting this. I'm not going to worry about it. So you've got the definition, which is where you define what the function does. The definition does not ask Python to run any code by itself. When you define a function, I see this happen a lot. Somebody will build out a function, and then they'll go run it. They'll think, okay, well, it looks like I'm done, and they'll go and run it, and nothing will happen. Because a definition is not a request to the interpreter to execute any code. No code is executed on the definition. It just says, if this code is executed, this is the code that you would execute. The invocation is where the code is executed. I use the term invocation as synonymous with call or calling. It's actually more formal to call this calling a function, to say there's a definition of a function and then the call to the function. I tend to avoid the term call and use the term invocation because I find call confusing, because a lot of learning Python or a programming language is learning what things are called, and it's just kind of a name conflict. So I will tend to say we're defining the function and then invoking the function. Know that anywhere where you read or hear outside of this class, or if I say call the function, it is the way I'm using it is a synonym for invoking the function. So when I say invoke or invocation, you can think about that as synonymous to calling the function. So those two terms mean the same thing for these purposes. Cool. So I'll just keep that there. We'll do this. So let me show you a quick function. I'm going to write a factorial function. So I'm going to say def, and then I get to name the function. So the def keyword is short for definition. Sometimes you'll hear these called definitions. Most people just universally call them functions, though. So we're going to define a new function. So in order to tell Python that, we say def, and then the function name. So I'm going to call this factorial n. And I had somebody saying they didn't know something about this in study hall, and I didn't get to follow up with them about this. So I think you're in prep today. So I'll answer your question from study hall in here since we're looking at factorial. We say def to tell Python we're defining a new function, then we name it, and then after the name, we have to put parentheses. The parentheses tell Python what are the names of any inputs and how many inputs would this function have. Occasionally, you will write a function that doesn't have any inputs. It's not that common. I think probably the most common place to do it is in your main function. We're getting a little out of scope here, but this is a pretty conventional way to structure a program. I have a main function that's actually being executed here in this different document, and main often doesn't have any inputs in it, but we're not going to really get into that stuff. So occasionally you will write a function that doesn't have any inputs, but it's not common. Usually your function will have 1 to 3, 1, 2, or 3. It's not common for a function to have much more than that. If you're writing a function and it's got to have like 6 or 10 inputs, you might want to like sit down and think, like, maybe this needs to be 2 or 3 functions, or maybe it does need to have that many inputs, but there might be other ways to like kind of condense that down. So you don't want to necessarily, in a lot of cases, you're going to want to avoid writing functions with a ton of inputs and functions with absolutely no inputs. So usually 1 or 2 or 3 inputs is what you see. Maybe 4. Maybe 4 is common too. So factorial, in order to perform a factorial, if you don't know what factorial is, the factorial of a number is every number starting from 2 up to that number multiplied, right? So factorial of 4 is 2 times 3 times 4. Factorial of 7 is 2 times 3 times 4 times 5 times 6 times 7. That's how you calculate factorial. And we're just going to model that process right here. I am going to use a for loop, which we're going to learn about tomorrow or the next day. So what I'm going to do is just make an accumulator. I'm going to say prod equals 1, and we'll say for I in range 1 2 to n. We want to include n, so I'm going to say n plus 1. That'll actually include n. And then prod times gets I. To the person who is asking in study hall about the star equals, this times gets, this is the same as equals prod times I. We talked about syntactic sugar, so we did cover this concept. I don't blame you for forgetting because the context looks pretty different than what we talked about. And usually you'll see plus equals. But just like if this were plus equals, this would be rewritten as prod equals prod plus I. If I do times equals, or times gets, I should say times gets, it gets rewritten as prod equals, as prod gets prod times I, right? So that's just an accumulator operation. And then we're going to return prod, right? So if you don't understand the for loop here, what's happening here, um, there's not terribly a whole lot going on here. We'll get to that in a future lesson soon. I do want to just kind of show this to you, just so you kind of have a sense of it before you get into it. So we'll just call all this the process. You don't need to know exactly how it works from here, but we'll talk about kind of some of the parts of this. So notice this return keyword. This return specifies what we want the function to output. So anytime we're defining a function or learning a function that is already defined, learning how to invoke it, we want to keep track of a few things. We want to keep track of what its inputs are and the types of those inputs, and what its output is and the types of that output. So in order to specify what the inputs are, we have to have parentheses. They're not optional. And then we just, however many inputs, this takes one input. If this took two, maybe I would call it n and m. N comma m is how we would make a function with two inputs. Then we're done with the head of the function. Then we would write a colon, and the colon just says the head of the function is finished, and now we're going to go into the body of the function, right? And this is just like ifs that you learned, right? You write the head of the if, you write a colon. The colon is like the neck because it joins the head to the body, right? So then you write the body of the function. So just like with an if, right, we indent all the code that we want to be a member of this function. We indent it underneath, right? And then we do our process, whatever this process is. In this case, you know, if you don't understand exactly what this code is doing, you're going to learn about it soon. Don't worry about it. This is the process that will calculate the correct value of the correct factorial value for n. And then at the end, we have a return. And return, you think about what the return means. Return means to give back, right? If I gave you some apples and you returned to me an apple pie, right? This is a weird analogy, but then you'd be a function that, given apples, returns apple pies, I guess. I don't know. So you can think about like that's a silly analogy. It worked better in my head. But a return just means that's what the function gives you back. You get back, in this case, whatever the value of prod is. Yeah, functional chef. I do a lot of food analogies. That's my go-to. Yeah, so return just means this is what it's going to give you back. So you can think about it as synonymous with output. Now output, unfortunately, you can't just write output. This is not a meaningful word in Python. The meaningful word is return. Something special happens when a function encounters a return, which is that it stops any code that's any more code from being executed in that function. So if I went down here below the return, you know, and at this stage the return has definitely been run, right? It's not hidden under an if. You know, it's not hidden under an if that may say, well, sometimes it'll run and sometimes it won't, right? Like it's definitely been run because this for loop is complete and we hit this return, right? So if I have code under here, it's weird. Python will let you do this, but this is dead code. So this line will never run. So this is what we call a dead line or dead code. Because it will never, it's impossible for for this line 105 to ever be executed by the interpreter. It's just there, And like I said, Python will just let you leave it there. It won't give you an error or anything. I kind of wish it would, but it doesn't. I think there are linters and stuff to catch that, but yeah. Okay, cool. So if I run this code exactly as is, what's going to happen? Yeah. Somebody's saying it's going to return 2. Prod will be returned, but not printed. That's interesting. Okay. It'll return the factorial. The code will run in the back end, but not return anything. Will not print the result to the console. Okay, well, let's just say I run. You're right. I don't have a print in here, right? So that is fair to accuse me of asking a trick question. Not that you did, but I'm accusing myself because let's be honest, that's what I'm doing. We all know I'm asking a trick question. So that would be grounds for this to be a trick question all by itself. So let's say before I return, I'm going to print prod. So if I run this code exactly as is, what's going to happen? And am I still asking a trick question or not? We may never know. Nothing, and I'm still not? Oh, well, you got me. I mean, I'm definitely asking a trick question. The trick question is definitely a trick. So I admire that answer. It'll print 1 in this case. Okay. So I'm about to run this code. Notice the little blue circle up here means this document is not saved. Since it's not saved, it hasn't been run. That's how I have my things set up. So as soon as I save this document, it's going to execute. So we've got a little bit of a, maybe we have a little bit of a betting pool. Somebody says it'll return 2. Somebody says it'll return 1. Some people say NA. Some people say something, right? Just to be clear, I'm going to print fin. I'm going to print fin. And fin just means the program is finished running, just so we know that the program has run, right? So final answer, what is this code going to run? Aside from fin, we know it's going to run fin. It'll print 1. Any other votes? Error in isn't defined, nothing. This is great. See what all of you are doing right here? There's a lot of thoughts going on here. And this is what I do. Anytime there's something that I'm not sure about, I'm like, well, what could it be? And I do exactly what all of you are doing. And I encourage you to do the same. You know, what I'm doing right now, asking you this question, isn't to see, well, who's got it right? I don't really care. I want you to think about it, I just want you to think about what might happen, right? And what you think your expectation is, right? So I'm going to run it. Fin. So we got fin. This ran. That proves that we ran the code, the program, all the way down to line 109. We passed this, but there was nothing above it. Let's scroll above it. Let's see if there's anything else. Nope. This is just the last prompt, right? So nothing happened. So this is an important moment. So we defined this function, factorial, but we didn't ask Python to run it because a definition, again, is not a request to run any code. Python looked at this, it parsed it, and it said, okay, that's how I do a factorial function, I guess. I'll remember that if I ever get asked to do a factorial function, right? Obviously, I'm anthropomorphizing the Python interpreter more than a good scientist should, but that's what I'm doing. So regardless of whether I have a print here or not, there is no invocation of this function. Think about what's the value of n? There's no value for n, right? N is just a thing. You can see it shows up in my code once, but never is a value given for n. So if I wanted to calculate factorial, I have to think about it in the context of factorial of something. So factorial of 4. And the way I like to write my code, the way I like to structure things, I like my function to return something, and then I like to print the invocation. Print, and sometimes I'll do a few invocations. And if I say, a lot of times I'll just take a note on what to expect. Some of you have heard me talk about testing. There you go. So now my function works. I plug in this value 4, it gets plugged in to the value of n here. If let's see, print the value of n is, right? So I'm calling my function factorial of 4. I'm expecting it to give me 24. And let's just see what the value of n is. The value of n is, of course, I didn't even put in the value of n. I didn't even put in n. Okay. The value of n is 4. You can see that on that first line. And then I get 24. This 24 is coming from this line. So let's do this. The factorial, or I'll just say factorial 4 equals, oh, invalid syntax, Python. You know what I meant. I'm just kidding. So factorial 4 equals 24, right? So you can see this is factorial 4. This line is where that 24 is coming from. I know there's a little bit going on here, but we'll break this down, make it a little more bite-sized. So if this feels like a little bit much, we're gonna go through this and kind of break everything out into smaller chunks. I did want to show you something that was like minimal but complete, and I promise this will be a real super easy basic function for you in a couple days, if it's not already. Cool. Do you need to invoke by typing factorial 3 in your console? There's kind of a way of executing your code like that. I always do. I execute my code in a little bit of a different way. I use a file watcher that I had to install with a little bit of a process. I tell it to watch. I say -w for watch. Dot means the entire directory. It just means if anything in this whole directory that it's running in changes, which means if I save a document, it detects a file change. And then -x means execute. And then I execute the Python interpreter. I say IPython 3, and then I point it at the file that I want, which in this case is located at source Python main, which is just a path to the file that I want to execute. And that lets me execute every time I save the document. And it means I don't have to like do much of a hotkey command or like use my mouse and like change from, click on the in the editor and then click in the terminal and then type in the command. So it just means it just runs every time I save the document. And it makes me save the document constantly, which is good because, if you've ever written 30, 40, or 100 lines of code and then had your computer run out of battery, you lose all your work. So now I have to save my code constantly in order to run it. So it's a win-win. Okay. Can't you make factorial even easier other than this so there is a factorial that's built into Python in the math module. Somebody's bringing this to our attention. And yeah, so we could import math. I could say from math import factorial, and then we just bring in a factorial function, and I could say print factorial. But that takes all the fun out of doing it ourselves, right? You know, factorial is an easy enough algorithm. You know, it gives you a good opportunity to practice uh, the sort of the process of coding, in addition to, you know, the logic, right? So the answer is I prefer to do things myself because I'm a curmudgeon. Maybe, perhaps that's the answer. Anyways, no. Just looking through for questions here. Yeah. All right, cool. So let's break this whole thing down a little more. Let's kind of get out of factorial because I know this might be a little heavy, might be a little bit much going on here, depending on where you're at. So let's just write some real simple functions. So first of all, let's cover the anatomy of a function again. We have the def keyword, followed by the function name, followed by parentheses. Okay, I'm just gonna parentheses. If your function takes no inputs, it still has to have parentheses. You have to have the parentheses. I've seen people put them in, like, try not to put them in because they're ugly, and I'm laughing because that was me once upon a time. I was like, it just looks so weird to like have them in there if I'm writing a function without inputs or whatever. Good news is most of the time you're writing a function, it's going to have inputs of some manner. Yeah, and then we have a colon, and then the body of the function. The body of the function is just indented, and it's whatever code we want. Inside of the parentheses, we just put the name. It's the identifier portion of a variable. You know, remember I was talking about variables, and I was like, here's a variable, and here's what each of the parts of the variable are called. The name is called the identifier, or the name, or the variable name, but I'll usually call it the identifier. Then you have the assignment operator, then you have the value, and that whole thing is called the variable, and usually when we're using them, we just call them variables and we know what we mean. But when we want to talk about just the name, I'll call that the identifier. So the parameter 1, parameter 2. So the parameters, which is more formal name for the inputs here, are just the identifier portion of a variable. So they're like a variable without the assignment operator or a value. And that's actually what makes functions useful. That is like the thing that makes a function useful, is that you can name the inputs without giving them a value. And then if you notice up here, right, I said factorial takes in n, and when I defined it, I didn't give it a value. If I gave it a value, there wouldn't be a point in writing a function, because what I'm saying for the input is, I'm going to tell you the value later. Like, I'm going to tell you the value when I go invoke the function later, right? 4 or 5. And now I have a tool that will give me the factorial of any number that I give it. So yeah. Okay. So let's just write a real simple function. Let's say def, and what should this do? What should this do? Let's just say it adds, it's going to take in a number. So I'm going to write a little bit of a doc string for this first. Documentation string. You don't have to do this every time, but I'm going to do this so we have a clear idea of what we're supposed to do. So it'll take in It'll take in a number as an input, and it will return that number plus 10. So we're going to say def add, I'm going to call it add 10. I'm going to call I could call my number weasel fingers, and I could return weasel fingers plus 10. Now this is not a great function name, so parameter name, so I think I'll call it in instead. I just wanted to give it a silly name, just so you don't, you get the idea. You can call this parameter name, you can call it anything you want, including weasel fingers if you wanted to call it that. So I'm going to call it in though, because that's better. It tells me that it's a number and it's a nice short name. So add 10 is going to take in n as an input, and it's going to return n plus 10. So using this function that I just wrote, I'll leave it to you all. How would I make the number 30 display on my console using this function? Make sure you run your code in your REPL. And do always submit in a formatted code cell, please. That will help me read it. Missed a bracket? Yeah, no worries. Soon you shall train your eyes for missing brackets. I'll stop. So the goal is to use this function. We're not going to alter inside the function. We're not going to add stuff. No adding stuff here. So we're no adding stuff to the function. We're just going to, now that it's defined, using that definition, we want to display the number 30 using that function onto the console. Okay, cool. So feel free to put in your answers if you still got them. I'm going to show the answer here. So if I print, so this function returns something. It gives me back a value, and I can see that value if I put the call in a print, or if I could save that value that it returns to a variable. Why don't I do that? I'll call it res for result. Res is a pretty common shorthand for result. It definitely is in my code. You'll see other people do it too, but I use it all the time. Just it means result. So I'm going to say the result of add 10 of 20, add 10 to 20 is the result, and then we're just going to print the result. So you can see here, result is, add 10 takes in 20, and now points to the value 20, and it's going to return n plus 10. N is 20, 20 plus 10 is 30. So this gives me back the value 30. So this is like saying res equals 30. It's just like, this syntax probably makes sense to y'all. It's exactly the same. Add 10, 20. Gives me 30. Print res 30. Good to go. Alternatively, if I didn't want to save it in a variable and do the extra step, I could just print it out directly. 30. Same deal. Same thing is happening here. The variable just adds kind of an extra intermediate step. I don't know if it's useful to capture it in a variable. You could do it that way. Great. Let's just do a super duper quick. Let's see here. I'm going to give you a doc string, and you're going to implement a function according to it. Okay, this is going to be a real simple one. So a doc string, it's short for documentation string, and it's structured generally like description, inputs, return. Return is output. I don't know why I'm capitalizing things. So the description usually includes the name. We're going to say double takes, and double is the name. I'm just going to put that in backticks so it's clear that I mean that to be a function. Double takes a number and returns a number that is twice the value of the input. So inputs, I'm going to say n. I want to note the type of n. I'm just going to say num. This is not a formal type specifier, but that just tells me int or float. This is my own shorthand, so I get to write it however I want, right? So n is a number, it's an integer or a float. The number to that the double is calculated against. God, this feels silly to say that. Return, we don't need to give it a name, but I'm just going to say it's going to be another number, and it'll be return a number which is twice the value of n. Okay, so that if it's not clear, you know, what this function does, it kind of feels silly. I'm like repeating myself. Okay, so here, we gotta wait for Slack to load. That's great. Okay, so here's your doc string, and I'll just put a minute on the clock. You want to do a definition, and I want to see you invoke it in a print. You can just do a simple invocation inside of a print and just pick a value to throw in there. It doesn't matter what. About 30 seconds. And do run your code in REPL before you submit it. You know, don't like I said, don't hold yourself to the standard of like, oh, I've got to be able to do this without running it. That's like, there's no realistic workflow that actually looks that way. I don't know. Maybe there is, but it sounds miserable. So I like to run my code constantly. So that's what I recommend. Okay, great. So I'll show a solution. I always like to start with my invocation. So print double of 3, and just because I'm forgetful, I like to take a note of what I expect. So I have a complete test, right? This test says this function with this input should give me this output. So this is a very, very simple test. Some of you may have heard of test-driven development. Test-driven development uses more complicated tools. At the end of the day, this is what test-driven development is. At the heart of every test is, for this process and this input into that process, I expect this result. Tests can get way more complicated, but this is a small bite size, but formal workflow. So twice 10 is double 10, excuse me, double 5 is 10. Double 12 is 24. So I have a couple tests now. So presumably, if I see, when I run this, if I see 6, 10, and 24, I can be pretty darn certain that my function is working correctly. Obviously this is a pretty trivially simple function. I don't think any of you have trouble thinking through like what multiplication means, but if you've made it this far at least. But we're not just thinking about how to multiply two numbers, because you already know that, but we're thinking about how to correctly and completely structure a function and what all the parts of the function are. And that's worth practicing by itself. So with this one, double takes in n, and we're just going to return n times 2. So I got 6, 10, and 24 and expected 6, 10, and 24, so I can be pretty reasonably certain that that function is working as intended. Great. Okay, so those are functions with one input. I know I can English is. Let's do a function with multiple outputs. So let's just kind of follow the theme. Let's do another one. I'll do another docstring here. Actually, I'll do this one because it's a little unfair if I just throw you in that one. So let's do subtract. So I'll do one for subtraction. I'll say def. Oh no, I'll do addition. Addition. And we're going to take in two arguments. We're going to take in a and b. Of course, these could be x and y, or n and m, or poodles and hockey, whatever you want. But a and b makes sense to me. And then we're going to return, surprise, surprise, a plus b. Okay, so how would you imagine that I would call this function? What if I wanted to call this function and I wanted to add the numbers 7 and 8? I want to call it inside of a print so I can see it. Go ahead and put it in Slack. How might you imagine? And this is another one of those moments, like test your intuition. What is your, like, looking at this, how might you guess to call this? Or maybe you know this much. This is maybe not news to you. Great, yeah. 7, 8. Boom, 15. Now that I ran it, I know that 7 plus 8 is 15. So I'll note that there as my expectation and pretend I knew all along. No one will be the wiser. Okay, cool. So let's do one with subtraction. I mean, I don't even think I really need to write a docstring for this. But subtraction is going to take in, the function name is going to be subtraction. It'll take in a and b, and it will return the result of a minus b. And then test it with the values 10 and 6 and 6 and 10. I'm going to put a minute on the clock starting now. Yeah, I can repeat that. So you're going to write a function called subtraction. It's going to take in two values for its inputs. You can call them A and B. And it will return the difference of A minus B. And then when you call it, I want you to write two tests. One with one that will give you the result of 6 minus 10, and the other that will give you the result of 10 minus 6. We'll just do another 30 seconds. And when you submit the definition and the two invocations, the two tests. Okay, we'll wrap it up there. Go ahead and get in your answers. Okay. Great. So, def, I'm gonna, oops. Like I said, I like to start with my invocations. Subtraction. We want to test 10 minus 6. What's 10 minus 6? That's going to be 4. And then 6 minus 10. Let's just do 10 minus 10 too. Why not? 10 minus 10 should be 0. And 6 minus 10 should be negative 4. Okay. So not a terribly complicated function, but it shows you how you can write a function with two inputs, right? So I want to talk a little bit of vocab here. So I've been calling these inputs. In general, you'd be understood when you talk about functions having inputs. But I'm using that word to kind of simplify the concept. When we define the function, we call the inputs parameters. So A and B, the identifiers, just the identifiers, the A and B here are parameters. I think you might say, well, parameters kind of means limitations or constraints, boundaries, something like that. But that's what we call them, parameters. So these are the parameters. A and B are the parameters. And essentially they're just inputs. Regardless of what what the word parameters feels like it should mean in this context, you can think about it like these are the names of the inputs to the function at definition time. When we invoke the function, we call the inputs arguments, right? So parameters are the name portion of the variable, kind of, the identifiers, and arguments are the values, right? Arguments just have to evaluate to something that is valid for that parameter, right? So these arguments are specific data points. Parameters are generic, right? A and B are not specific. They do not have specific states. They just are names for something that we're going to plug in later for arguments, right? The act of plugging in these arguments is called passing. So we talk about passing an argument. Unfortunately, not to be confused in any way, shape, or form with the aforementioned pass keyword. So I know I mentioned pass before, P-A-S-S. This keyword pass has nothing to do with the kind of pass that I'm talking about now, right? We would say I would pass the values 10 and 6, pass as in like hand off. The pass keyword just means pass as in like don't worry about it. It's a way of telling the Python interpreter to not throw an indentation error when it expects an indented block. But that's basically pass's only job as a keyword, right? So it's weird that we talk about passing arguments to functions, and then we have a keyword called pass that has nothing to do with passing arguments to functions. So it's kind of a weird thing, but it's just something you have to know. Okay, so the three terms here, parameters, or let's say A and B are parameters. A and B are parameters. I'll say 10 and 6 are arguments. When we give arguments to a function, we say we're passing those arguments. So parameters, arguments, and passing. And I'll just kind of highlight these. You can refer back to this if you want a little section on the notes. So we talk about passing arguments to a function. Okay, so let's look at some variations of this. I'll just use the subtraction function. So you might wonder what would happen if I gave, so this says I take in A and B. So let's look at some ways that we can do this incorrectly, because there's a few. And well, first off, right out of the gate, what's going to happen here and what's wrong with it? It's kind of obvious what's wrong with it. It's kind of obvious, you know, I mean, we don't have the parentheses or the inputs. But if I run this, what's going to happen? What do you think is going to happen? Yeah, no args. Yep, exactly. Yeah, that's one thing for sure. Maybe I would get an error. Maybe, you know, and this is the point, like speculate. And then if there's something that seems obvious to you, maybe that's it. And maybe it does that. Maybe it doesn't do that. Either way, you learned something. So maybe this gives me an error. Maybe it has some default value that it gives me. Maybe it does something really weird, like it prints out the location and a memory address or something. Probably doesn't do that, right? Actually, that's exactly what it does. So this is a weird one. Totally prints out the name. If I write a function, or if I call, it's not really a call. It's this is just specifying the name of an existing function without invoking it. So this is an uninvoked function. And it is important, we'll get to this later, this is valid behavior and it needs to be valid behavior. There are times when this behavior is important, but it's really weird if you're not expecting it. Prints out the name and the memory address in which it's located, right? So this is, I don't know if this is literally corresponds one-to-one with the name of a memory address on my computer. I think it's probably just a name that the program gives a memory address. So, but yeah, this just tells me the location of the function called this, right? So this is valid code. This is not an error. It's just probably not what you expected, right? So that's one thing. Okay. So let's look at a few variations, right? So I know in order to get it to do something, we have to invoke it. Okay, so I'll put the parentheses on. I've successfully invoked it. If I run the code now, what do you think is going to happen? Maybe it'll give me, I'm not satisfying A or B. So think about this one. I promise I won't cut in again. I'll let you actually get in some answers for this one. What do you think is going to happen with this one? Maybe it'll give me the, since I'm not satisfying the answers or the arguments, maybe it'll give me the address again. Or maybe it'll give me an error. Maybe it'll give me an error exactly like the error that somebody pasted in that would be a good error if this did give me an error. I'm really leaning into the trick question. Yeah, it totally gives me an error. Also, to the person who pasted in the error that this gives me, that's a totally valid way, just so everybody knows, if I'm asking, hey, what does this do? Feel free to just run it and see in Replit and see what it does, I would say think about it for a second, but just, yeah, feel free to run it. And my trick questions are very hollow. They can be foiled very easily. Okay, cool. So this gives me an error. So this says subtraction missing 2 required positional arguments. So a positional argument means that it knows which value to plug in based on its position left to right, right? And that's why I had you test the subtraction in this way, so it would be intuitive that if I plug in 10 minus 6, well, 10 is going to get plugged in for A, and 6 is going to get plugged in for B. Therefore, we're going to get 10 minus 6, versus if I plug in 6 minus 10, 6 is going to get plugged in for A, and 10 is going to get plugged in for B. So therefore, we're going to do 6 minus 10, which is going to give us negative 4 instead. So that should give you some intuitive sense, right? The order that you pass in the arguments matters. The first argument corresponds with the first parameter. The second argument corresponds with the second parameter. If we had a third and a fourth, the third argument corresponds with the third parameter. The fourth argument corresponds with the fourth parameter, et cetera, et cetera. So and notice it also says they're required. It is possible to write functions that have optional arguments. We'll probably get to that in the next class. We're almost out of time here today, which is incredible. So we'll go a little deeper into functions next time, probably do that for the first half of class. And then probably we'll get into lists and loops next time as well. So it does matter. So it says these are required positional arguments. We didn't talk about how to do non-required arguments yet, but it's possible. And these are positional arguments, which means they're taken left to right. And there's another kind called keyword arguments, and we'll also get to that later. So I have to supply values that satisfy, or I have to supply arguments that satisfy all the parameters, right? So, if I don't pass anything, function expects 2, it gets nothing. If I give it let's say one, but not the other. Oops. One, but not the other. I get the same error, except it says missing one required positional argument instead of two, right? So if I give it both, then this is going to work. So this is going to give me back 4. If let's say I give, let's just do that. Let's say I give too many, we're going to get sort of a similar one, similar error. It's going to be like that. And of course, this would be true of if I give it more than 3 as well, right? So if I give it too many arguments, it's going to say subtraction takes 2 positional arguments, but 3 were given. So it's a slightly different error in terms of the way it's written, but it's the same basic idea. So when you define a function, if the function takes 2 arguments, it better have values for, you better supply 2 arguments for both of the parameters that were in the definition. One way or the other, it has to have a value plugged in for every parameter stated. Cool. All right. Well, we've got seconds left, so I'll wrap up there. This is a fun class. I had fun. I hope you did too. I hope you found it helpful and educational. Thanks for all the interaction. Thanks for being game to like. I know I asked for a lot of interaction and put this in Slack and put in your answers and stuff. We had some really good questions, which I really appreciate that. I really like it when people ask questions. Obviously, lets me know you're engaged, and I think it just makes the class kind of come alive, makes it vibrant and fun for me, and I think for everybody else too, hopefully. Cool. Great. Awesome. You all are welcome. I'm glad you enjoyed. You all go off and have a great rest of your night. I'm going to wrap up the recordings, and in a second, we will open up for questions. Pause. Stop the recording on Zoom, and now OBS.